Okay, and we're recording. So today's review session is mostly about the quiz. So it's covering the 2 Glaciers lectures as well as the one History of Antarctica lecture you've had up to this point, which is lecture 12, which covers exploration of the Southern Ocean and kind of the lead up to discovery of Antarctica, and then the early trips to Antarctica that involved seeing Antarctica and finding new science, and also an increased human presence on the subantarctic islands, but didn't actually involve people setting foot on Antarctica just yet. The lecture that I'll be recording for tonight, lecture 13, covers more of that, but that is not on the quiz. That is not on lecture quiz number 2. So lecture quiz number 2 is due this Friday. It's the second and final of the 2 lecture quizzes, and it's again kind of a midway check-in between the midterm and the final, just covering only covering material from the last couple of lectures. So you have 30 minutes to take it once started, and you get 1 attempt. It consists of 10 multiple choice and true or false, and there are 2 short answer questions. Actually, I did put 2 in. So for this quiz, the material covered are lectures 10 and 11 on glaciers, and then lecture 12, one of the history lectures. And then also there was a clip of Encounters at the End of the World that I assigned, and it's about the first 30 minutes of it. And when watching it, you don't try to kind of think about what you find interesting about the people and what they're doing in Antarctica and what their jobs are, because there will be a question related to that on the quiz. But mostly this review session will be about lectures 10 through 12. So midterm from, material from before the midterm will not be on this quiz at all. I do want you to remember that the final exam will contain material from prior to the midterm. It will be cumulative, so continue to study your previous material. And since I kind of have space for 2 lectures during dead week, I will do 1 lecture covering material since the midterm, and then I'll do another fairly short lecture just recapping pre-midterm material that might be likely to show up this time. But for this quiz, there is no pre-midterm material that you have to worry about, nor do you have to worry about lectures 13 and 14. There is another reading assignment I wanted to mention also that's now open. I need to actually update the description on Gaucho Space, but it is very similar to the previous reading assignment. It is just based on the scientific article this time, and I'll have some more details on the next slide. And this Friday, the lab that is due is actually the Antarctic Exploration Lab, which you don't need to have all of the background for it. Like, you don't need to have every detail about who Shackleton was before you do this lab, because this lab is actually mostly based on mapping their route. So it might be very worth reviewing your maps lab as well as the geography material from lecture if you want to get a refresher on latitude and longitude, and the pole, and kind of a sense of what the map projections from the pole look like. But anyhow, that is due this Friday, so take the time to talk to your TA and read the material if you have not done so already. Any questions about the upcoming assignment timeline in general or anything? Okay. And I did that yet again. The top bar of this thing is hard to see. So this is, I will put this on Gaucho Space. I need to still actually put these guidelines in the assignment itself, but this is what you're doing for assignment number 2. You're writing a piece that's about the same length as assignment number 1, and it is about as open-ended in that what you write about is largely up to you, but what you must address is what the goal of the people doing the research was, like what they were trying to find, and then you need to address what their results were and if that's what they expected. And in a well-written scientific academic paper, that should be somewhere in there. The abstract there'll be a little section called the abstract that is kind of a summary of the paper at the beginning, also helpfully. And that will summarize what they were doing, hopefully, because if it doesn't, then it's not a very good abstract, because that's literally what it's meant to do. If you're interested in geology-related articles, one database I suggest using to look for this is GeoRef, but there's other databases that you can access through UCSB's, the UCSB Libraries online system in biology and history, because I am okay with you writing about Antarctica-related history of Antarctica-related articles if that interests you more. Again, what subject you pick it on is very open-ended, but this time, instead of a news article, it's an academic article, like something where people have done research and then written about that research and published it. You kind of are functioning as the media commenting on research this time, actually. You're kind of doing the role that the people who wrote the articles that you were looking at last time for assignment number 1, you're kind of doing that now. You're doing what they were doing. You're writing about, you're reading the science that the scientists are putting out, or the history research that the historians are putting out, and then writing about it. And again, I will put this up on Gaucho Space also, and I'm very happy to look at articles before you do them. This is due, it's now due at the end of Dead Week. So I pushed it, I also pushed this back a bit. So you have quite a while to do this, but I'm just putting this on your radar now. Anybody have questions about that before I move on? Okay then, cool. So this review session is mostly targeted towards quiz number 2. And again, this is the material. Reminder not to worry about pre-midterm material at all. And it is due this coming Friday. So let's go ahead and start with the history of Antarctica, because I have not yet done that in a review session. So as for the history that's covered on this quiz, it's lecture 12, and here is a summary of the first half. And during lecture 12A, I talked about the lack of an indigenous population in Antarctica and why that might have been, mostly because of Antarctica's isolation from other large land masses. The fact that Drake Passage lies, the closest point to Antarctica is southern South America, and there are indigenous people there, but the Drake Passage is really dangerous to take a ship into. So they didn't really bother trying to go south, and also didn't really have the shipbuilding technology. The people in New Zealand might have gotten close-ish, but that's kind of speculative. And then Africa's quite a ways away also. Antarctica is uninhabitable for people, quite frankly. The current research stations need to employ a lot of technology for the people to live there. And it is, it's really like, even if it was a bit closer to, even if it were closer to these lands, it might have been found faster, but I don't think there would have been a population living there, because people really can't live in Antarctica. So Antarctica, nobody knew Antarctica existed for a very long time, until the 19th century, really. Of course, as European exploration expanded and they began to know more of what was around the globe, they began to speculate that, hey, maybe there is this other lost continent at the South Pole, because we don't really know what's at the South Pole. And the human imagination really does kind of tend to just put something there where there's a gap. Like, it's like, okay, we could imagine that it's just empty ocean, but it's kind of more fun to imagine that there might be this continent there. That's kind of one way I look at it also. But they really just didn't know anything. I mean, you've looked at some of the, at this point, you've reviewed the lecture and seen some of the maps of the world. And those maps, even the early maps they have, like in the 16th century, you can see the shapes of the continents, but they're very interpretive and very interpretive in how they proportion the continents. But anyhow, so we talked about the motivations that led to European explorations of the rest of the globe. So factors like colonialism, frankly, because people like Magellan were ending up close to Antarctica to look for trade routes between Europe and its colonies, or between Europe and the Spice Islands. And that's really why Magellan was even going there in the first place. He wasn't solely doing it for the purpose in itself of finding new land or making maps, even though that's long-term one of the most consequential things that came out of it. And there have always been economic factors going along with exploration too, which is a theme we see throughout the history portion of this course. For example, trade routes again. Captain James Cook, who we talked about in this part of the lecture, who did attempt to make one voyage to look for the mythical southern continent, also made a separate voyage to look for the Northwest Passage, which was a potential trade route between the North Atlantic and North Pacific that people thought existed. It does technically if you can get through the ice surrounding the Canadian archipelago. But and then going forward in the next part of the lecture, we talked a lot about sealing and whaling, how many of the discoveries of some of the sub-Antarctic islands and that kind of would lead to the discovery, and also the mapping, the early mapping efforts around Antarctica were done by people who were there for sealing and whaling, who were there to hunt seals for fur and whales for oil and for meat. But I mentioned the lost continent, and the concept of terra incognita australis was, again, the idea that there might be some hypothetical continent. It was kind of a generic name map makers and explorers and scientists gave to whatever might be down there, and they would just kind of draw it. However, for a long time, actually in this map, you can see South America is drawn here, and then they draw Tierra del Fuego, which is actually an island that is the southernmost tip of South America, but they draw Tierra del Fuego as being attached to Terra incognita australis. So many of the early discoveries that we talked about in lecture 12A were of what we now know of as the subantarctic islands. The surrounding islands like South Georgia, the South Shetland Islands, the South Sandwich Islands, that are now really important breeding grounds for, they have always been and are now really important breeding grounds for seals and for birds. And that was one reason why they were the target of commercial operations, and why they are now subsequently in the 20th century a nature preserve, 20th and 21st centuries a nature preserve. They've been a nature preserve since the 20th century. But this mythical continent did play a role in motivating global exploration. There was this search for science and search for expansion of knowledge thing that went largely hand in hand with the Enlightenment, and also because you can very much use science and your nation's knowledge as a way to grandstand with other nations, which is something we see throughout this also. Oh, there's a kitty on me. Okay. So a lot of the early discoveries were not of Antarctica itself, but of features like the Drake Passage. So Sir Francis Drake wasn't the he probably didn't go into the passage itself, but he and his crews correctly surmised that there was water south of Tierra del Fuego and not actually a land bridge to this mythical southern continent. So that's the main place he comes in. And again, like with the historical figures, you basically want to know why they're relevant to Antarctica and what they discovered, or what they were the first, or what they did first, or what they did that got them in the history books. So so Magellan, for example, is in the lecture because he did command the first crew that circumnavigated the world, even if he himself did not make it. And his crew were the first Europeans to discover the Straits of Magellan, which for a long time were the main trade route from the Pacific to the Atlantic before the Panama Canal was built much later. And that people ship traffic through the Straits of Magellan increased awareness that, hey, what is south of us? How close can we get to this mysterious southern continent? And it put that area on people's radar and motivated future exploration of the southern oceans. But slowly and not much. I mentioned Sir Francis Drake, and he actually he lived later than Magellan and actually commanded only the second crew to circumnavigate the globe. He made it, and Magellan did not. Remember that he was the privateer who was sailing around South America to harass Portuguese and Spanish colonies. He was the British privateer, or a pirate for hire. And relatively soon after his crew came close to the Straits of Magellan, or went through the Straits of Magellan and sailed a bit south to Tierra del Fuego to just see what the wind patterns were like, some other ships not too much longer after discovered that, yes, Drake Passage was a very stormy channel of water, that there was not actually land south of Tierra del Fuego. So I talked about John Davis for discovering the Falkland Islands, which are another one of they're not quite sub-Antarctic, but they're Southern Ocean islands. And he had an experience that will mirror that of some of the explorers I will talk about in subsequent lectures, because the stormy weather stranded him and his crew. They were forced to eat penguins to survive, and they made a break for their return home with just tons and tons of penguins on their ship, hoping to survive on that. It worked until it spoiled when they got to the tropics. But some of these people I only talked about briefly. Mr. Bouvet de Logier is known for discovering the island named after him, Bouvet Island. Antonia de la Roche was the person who had the first sighting of South Georgia, which is one of the larger and more important subantarctic islands. And they were kind of in there because actually for quite a while, there's not a lot in the way of discoveries. People didn't actually frequently venture into the Southern Ocean because, again, it was very dangerous. And we finished this lecture, this half of the lecture, talking about the 3 voyages of Captain James Cook. His second voyage was a voyage around the Southern Ocean, specifically chartered to look for the southern continent, and he crossed the Antarctic Circle several times. He made 3 separate attempts to head south, and he got quite close to the coast of Antarctica, but couldn't see it because of the ice and the fog, and he didn't dare bring wooden ships into the ice. And as we'll see later, the more successful efforts to get closer to Antarctica involved ships being built more strongly in many cases. But his discoveries were still important for setting the stage for Antarctic exploration for at least getting as close as he did and obtaining as many scientific specimens as he did. And one factor that impeded discovery for a long time was the fact that longitude was really hard to measure at sea for a long time. So that was something I lingered on for a little bit. How one reason the old maps look so wonky, and one reason also why shipwrecks were so commonplace, why these people struggled to navigate as much as they did, was because measuring longitude was really hard at sea, because longitude is dependent on time, and it was really hard for there to be a clock that accurately kept time at sea. But one was finally invented a little bit before Cook's voyage, and Captain Cook and his crew were actually some of the first to sail at sea with a marine chronometer, is what the timekeeping device that can be used at sea. That's what it's known as. And the chronometer played a large role in improving navigation and just making it safer and less costly to sail around the world. And that played a role in opening up exploration later. So that's a rough summary of lecture 12A and what I was trying to get across with that lecture. Does anyone have questions about this before I head on to the next part of to a recap of the next part of the lecture? And remember, I'm not testing you on dates. I'm not going to ask you questions about that. So please don't waste time memorizing those. They're in the lectures as a reference to kind of just give you a sense of when this is happening, and so that you can put an event to a date if you need to, if you're really curious. But I'm not testing you directly on those. Okay. And then in lecture 12B, we get to see Antarctica. We don't get to land on Antarctica, but we get to see it. So Bellinghausen, who was employed by Russia, was the first person to see it, but shortly afterward, Nathaniel Palmer of the US, as well as a couple of others, sailed south far enough to see land. And so Antarctica became public knowledge pretty quickly. There were a couple of basically coincidental sightings of Antarctica in pretty short succession, and the people were down there for different reasons. Bellinghausen was down there specifically to look for the southern continent, just further south than Cook had gone. They came equipped to deal with the ice better than Captain Cook and his crew. Palmer was down there to hunt seals, and the discovery of the fur seal, as well as the various baleen whales in Antarctica, prompted a lot of people to head south, a lot more people than before. I should say the discovery in the subantarctic islands, because the whales and the seals were known to live in places like South Georgia, and also just southern South America and the Falkland Islands in general, before anybody knew Antarctica existed. But as kind of grim as the history of sealing and whaling is, it did play something of a role in bringing more people south, because some of the discoveries of some of the southern subantarctic islands, as well as some of the mapping of the peninsula and West Antarctica in general, was done by people who were down there to be hunting. So something long-term, something did come out of it, but also ecological devastation came out of it. Neither the fur seal, which was hunted heavily for its pelt, nor any of the various baleen whales. And remember, baleen whales are the large whales that use that hair-like structure. That's what baleen is, the hair-like structure in their mouth to filter krill. They were hunted very heavily for their oil, because that was used to light lamps until electricity became more commonplace. And Antarctica and the waters surrounding it were a huge source of whales for the companies, a lot of them United States based, that were hunting them. So, and some of the people were there for scientific purposes. Some of them were there largely for economic purposes, like hunting whales and seals. Some of them were there for kind of a hybrid. James Weddell, the Weddell Sea, which is the sea east of the Antarctic Peninsula. It's named for him now, but he was technically employed by a sealing company, but was kind of using that as he was way more interested in the science and in making maps, and kind of just did his job and then took scientific notes on the side, and did a lot of mapping of the east of the Antarctic Peninsula. And people didn't really know what Antarctica was shaped like at this time, because people hadn't landed on it. People hadn't gone around the continent while staying close enough to the coast to observe. And Weddell attempted to go as far south as he could and set a new record, which is what some of these people are famous for. He set a new record for distance farthest south, and kept going through the ocean that would later bear his name. Decided to turn around when he was mere miles from land, hilariously, and deduced that in that part of the globe, water went all the way to the South Pole. It didn't. If he had gone just miles more, he would have gotten to land. But he set a record for new farthest south and got a bunch of features named after him later, so he didn't do too badly in that regard. And Palmer was more there to hunt seals, and he was noted for discovering one of the groups of the subantarctic islands, the South Orkney Islands, and basically writing one sentence about it and not caring about it because there wasn't a heavy seal population there. So his interest in areas tended to relate pretty heavily to was there a population of seals or whales that could be hunted. And as for some of these other figures, Mr. Dumont d'Urville is mostly known for searching for the South Magnetic Pole and determining roughly that it was in Adélie Land. That was where it was then. It has actually shifted since then, because since Earth's magnetic field is constantly shifting and relatively unstable, I shouldn't say unstable, it's just dynamic, shall we say. The precise location of the magnetic poles changes. It can change within a human lifetime. It's actually why when geologists include measurements related to geomagnetism in their maps, they will make a note of what year the map was made, because the Earth's magnetic field could have shifted a bit since then. But anyway, that's just kind of a side point. The Wilkes Expedition was actually the first that was ever funded by the US government for science, and it was again an example of science and practical concerns meeting. The trip was funded specifically for science, like to obtain specimens, make maps, and discover more of Antarctica. But there were political reasons involved. The U.S. wanted to compete with the Western European powers like the UK and France on an sort of an information and knowledge level, and it wanted to prove that it wasn't just this fledgling weak nation that couldn't do anything, which is what they felt that Europe tended to view it as. And then there were also purely economic reasons. A lot of the whaling and sealing companies were based in the US and New England a lot of the time. Moby Dick, hence that's whaling out of Nantucket. But even by the mid-19th century, the sealing and whaling grounds in the near South America and in the northern sub-Antarctic islands were just getting devastated, like the populations were just gone. And so they were pressuring the US government to look further south to find possibly more grounds for them. And that they did. That was one thing that came out of it, and the sealers and whalers went farther south and wiped out the seals and whales living down there as well, depressingly. And the Wilkes Expedition came back with so it wasn't just targeted towards Antarctica. There were several ships that went elsewhere in the world also, but both the specimens, including a lot of the birds and sea life that they obtained in the Southern Ocean and the islands down there, became part of the first collection that would become the Smithsonian. It was named something else at the time, but it's basically the Smithsonian. James Clark Ross, who's kind of the last person we talked about before people started landing on Antarctica, is a good example of someone who used improved ship technology to get farther south. He used battleships that had been strengthened to be able to withstand their own cannon fire, basically, and that helped his ships withstand the ice much better. And so he didn't get to land, but he got pretty close to land and could see the Transantarctic Mountains, could see Mount Erebus erupting, the volcano on Ross Island near McMurdo Base. And that mountain is now actually named after one of his ships. And Ross Island, which is where McMurdo, the big US base, is also named after him. Confusingly enough, there is a James Ross Island near the peninsula as well. And there is a Ross Island and a James Ross Island on opposite sides of the continent, which is hilarious to me, because he made several different voyages and visited both West and East Antarctica. So by the time that we stopped, we had gotten to the point where a lot more of Antarctica was known to exist and had been mapped, but not visited, and nobody really knew what was on the interior. People would start to wonder if there was mineral resources there, and also, as we'll see in the upcoming lectures, people just kind of wanted to. There were some people for whom the motivation was just exploration. Like, I want to be the first person to get to the South Pole. And that's what we'll get to in the upcoming lectures. But that's about it for the history covered on this quiz. And does anyone have questions before I move on from that?
Could you go over the Bellinghausen's contribution?
He was the first person to see Antarctica. Barely, because some other ships saw it like days after he did. But he was Russian. His family was of German descent. This was when the Russian Empire controlled a good amount of German-speaking territory also. But he was sent by the Tsar for scientific reasons to try to find this continent, to try to find the mythical continent, and he did. It was just kind of hilarious because their thunder got stolen by American and British ships seeing it almost immediately afterwards. But does that make sense?
Yes. And I was going to ask, for the quiz, should we also keep in mind where like the individuals' countries they belong to or what countries they represent?
I am not explicitly testing you on that, but it might help you. Knowing it will probably help you answer the questions better, because again, it's context and might make some clues stick. It might make clues jump out to you better. So it's worth knowing. I haven't really been able to touch on the grand scope of the geopolitics because, well, for one thing, I'm a geologist and not a historian. For another thing, there's a lot more I could go into, but there's time concerns, and I also don't want to overwhelm you all with long essays about why Russia wanted to compete with the Western European powers, etc. But I kind of tried to touch on that a little bit at least. So it can be helpful to be aware of their nationalities just in terms of thinking about themes like competition between powers and colonialism and whaling, because a lot of that was done by American ships, etc. Other questions or follow-up to that or anything? Cool. So that is about it for History of Antarctica. I am going to very quickly recap some of the glacial-related material. There is a review session dedicated to this also that's happened earlier, and that's been recorded if anybody wants to take a look at that. But you want to remember the physical shapes of glaciers, like ice sheets, ice caps. And then the various non-continental glaciers. You want to know what a glacier is, how it's defined. A glacier is defined as ice moving under its own mass. And you also want to be aware of features like subglacial lakes and rivers, and ice streams, the parts of glaciers that flow faster, and ice falls. And we also talked about what happens to glaciers when they meet the ocean, how in Antarctica, glaciers continue to flow out over the ocean as ice shelves, and those break apart into icebergs when the heat of the ocean starts to warm them up enough. That is completely separate from sea ice, which is just the seawater freezing. The seawater freezing without taking the salt into it, because again, that is what drives Antarctic bottom water formation. And again, that's not, I'm not going to be testing you on oceanic circulation on this on this quiz, but the connection between sea ice and Antarctic bottom water formation is a good thing to remember, because that's something that could potentially be a topic for the final exam. This is another distinction that you want to keep in mind, the distinction between cold base and warm base glaciers, and how that's separate from the categories that are based on the shape of the glaciers, how most glaciers in Antarctica are so cold that they don't reach the temperature, even though at the bottom of glaciers, because the pressure is higher, technically water can be liquid at a lower temperature, at a colder temperature. But in Antarctica, the ice is so cold that there is very little meltwater, even at the bottom of a glacier where the pressure is highest. So glaciers in Antarctica don't tend to have a lot of meltwater, and they don't tend to be very well lubricated. That in the long run means that they tend to move by plastic deformation. They tend to flow slowly downhill, as opposed to basal sliding, which is very heavily driven by the presence of meltwater at the base. Most glaciers that are not found in Antarctica or Greenland, the sunlight heats them effectively enough that the ice temperature actually about follows the pressure melt temperature of water. And thus, there is a lot more meltwater, and there is a lot more outwash. There is a lot more of the sediment carried. There's a lot more of the sediment that's carried by meltwater, and there's also more lubrication. Does anybody have questions about this or varieties of glaciers that if they missed the last review session, or if there's anything particular they want me to go over? And these are the exact same slides from that. I just stuck these in here again. But we also talked about how glaciers can move in two ways. They can move by basal sliding with the meltwater lubricating them, or they can change shape slowly as they move downhill, and the ice crystals can move around and rearrange instead of breaking. And how in some cases, when glaciers do experience relatively sudden stress, the ice will not have time to deform in this way, and the ice will break and form a crack, form a crevasse. So this is what crevasses are. The crevasses are the cracks in glaciers that form when glaciers have to flow around a curve relatively suddenly, or glaciers flow over mounds underneath them, or glaciers flow over rough, difficult to erode terrain underneath them. And speaking of erosion, a lot of lecture 11 was focused on what happens to the rock underneath glaciers, because in Antarctica, outside of wind, glaciers are the main source of erosion. They're the main force that sculpts the land into mountains and valleys, that breaks the rock down and takes it out to sea. And glaciers can either pluck, which is an interesting process when a glacier goes from being warm base to being cold base all of a sudden, basically, at least in one spot. What happens is that pressure builds up as a glacier struggles to flow over it. It's maybe flowing over a type of rock that doesn't get broken down very easily. Volcanic rocks often are more resistant to erosion than sedimentary rocks. Rocks that form from lava flows break down less easily than sandstone, for example. But if you have an example like that, the pressure buildup will allow for more melting to occur. And this does occur in Antarctica, actually. In Antarctica, the pressure buildup can actually bring that ice above the pressure melt temperature at that pressure, and you can get meltwater forming. But then when the glacier gets past that resistant mound, the pressure will drop again, and when the pressure drops, the water will freeze again, and the frozen water will be frozen to the rock underneath it, and the glacier will still be moving, so it'll kind of just rip the rock off in a large chunk and pluck it off, and it'll leave. And not to make too gross of an analogy, but it's kind of like if you pick at your scab, you end up, it kind of leaves a mess behind, and plucking leaves chatter marks. Plucking leaves evidence behind in the form of chatter marks. Most glacial erosion is based on abrasion, though, not ablation. My apologies there. And abrasion is when glaciers are just slowly grinding down the rock underneath them, grinding them into tiny pieces. And we spent a while talking about the products of glacial erosion, how most glacial sediment is till, which is the mostly fine-grained, but then really poorly sorted mix of sediment that's just pushed to the front of glaciers, because glaciers grind the rock underneath them, but they also sort of bulldoze everything out of their way. So some larger boulders that don't break down as easily get mixed up in them too. And that is the type of sediment that is in the terminal moraine, at the pile of sediment at the end of the glacier. And till becomes diamictite if you turn it into solid rock, if you lithify it. And then we also talked about some other products like outwash, which is the sediment that gets carried by the meltwater at the end of a glacier, if there is meltwater. Glacial flour, which is the very fine-grained, and varves are the seasonal pattern you get in lakes that have glaciers feeding into them. And then we have glacial flour, which is the silt-sized quartz ground down by glaciers that gets deposited by meltwater in lakes and in bays, and it stays suspended in the water, so it noticeably colors the water a turquoise color, because lots of quartz in the water does that to light. And then how some of the bigger products are glacial erratics. And glacial erratics are the large boulders left behind by glaciers, and then sometimes also glaciers carry large boulders underneath them, and those get carried out to the sea in places like Antarctica where there's an ice shelf, and as the glaciers break up and the icebergs start to melt, the large boulders stuck on the underside of them fall to the ocean floor and get buried in sea mud, and scientists then can find them later in the rock record and determine that there were glaciers that actually got to sea level there, because they stick out quite a bit. And I skipped ice rafted debris, but that is everything that's carried on the surface of a glacier. So before I shut the recording off, does anybody have questions about any quiz material, or what to cover, or where to find past review or anything of the like?
So is like the quiz gonna be like 50% like glaciers, 50% like people discovering Antarctica?
Slightly less. It's going to be more 60-33, because there's 2 lectures on glaciers and only 1 on discovery of Antarctica. So it's going to be like 66% glaciers, 33% history. I just spent more time on history here because I haven't done a review session on that before. Whereas I did a previous review session on glaciers, and there's a recording of that goes in more detail with some of this stuff. Does that make sense?
Okay. Yes. Thank you.
Yeah. Maki says hi. Okay, I'm going to go ahead and shut the recording off then. So thank you for coming, and oops, I did that in the wrong order. That's whatever.